Okay, so very good morning to all of you.
Mm, Good
Good
morning, sir.
morning, sir.
Good morning, sir.
Okay, so in the last lecture, we have covered up to the unit of force. We have seen the definition of force and then some of the unit of the force, Newton, kilonewton, meganewton, giganewton, that we have seen. Now the next part for this is our characteristics of the force. So before moving further, please tell me that are you able to see the whiteboard and my voice is loud and clear to you?
Yes, sir.
Clear, sir.
Okay. So we will see the next part. Now the next part is the characteristics of force. So characteristics of force. Okay. So basically, what are the characteristics of force? Now suppose if I draw one diagram here, this is the surface now, and if on this surface, suppose this block is kept, a block is kept, and now on this block, a force is acting like this. This is the force which is acting on the block. Let us assume that this force is P kilonewton. This force is P kilonewton. Then what are the characteristics of the force? See, this P kilonewton, P means what? It may be 1 kilonewton, 2 kilonewton, 3 kilonewton, 4 kilonewton, 5, whatever may be the number. Okay, this P represents you the magnitude. What this P tells you? This P tells you the magnitude of the force. Okay, after that unit of the force is given, then this arrow tells you the direction of the force, in which direction the force is acting. This tells you by this arrow. So this portion of the arrow, front portion, it is called as head, arrow head, and the back portion of the arrow is called as arrow tail. So from the by looking at the head of the arrow, you can tell the direction of the force. Then you can see here this force is applied at this point here, this point. So this is called as point of application. This point is called as point of application. And now if I extend this force, see, if I extend this force by this dotted line, if I extend to the forward side, and if I same I will do at the back side, this line is called as line of action of force. This line is called as line of action of force. Fine. P is nothing but magnitude of the force. By looking at this arrow, you can judge the direction of the force. You will come to know that where the force is exactly going, the direction. Then at the point where the force is acting, this is called as point of application of the force. And this dotted line which I have extended from the head of the arrow and from the tail of the arrow, this is called as line of action of force. So on this line this force is acting. So this is called as line of action of force. So we will see this one by one. So in the characteristics of the force, our first point is magnitude. Our first point is magnitude. Magnitude of the force. Magnitude. So how do you define this magnitude? So magnitude, it is the quantity of the force. It is the quantity of the force, whatever may be the quantity, 5, 10, 100, whatever may be the force. Okay, so magnitude is nothing but it is the quantity of the force. Here the magnitude is P kilonewton. Next is the direction. Next is the direction. So what you can say about the direction? It is the line along which force is act, the line along which the force is act is it is known as it is known as is known as line of action, and the arrowhead points points the direction of force. Direction of force. So in the direction we have covered both the points. This is nothing but this is our line of action. This is line of action. This point is nothing but this is point of application. This is point of application where the force is applied. So both the points have been covered over here. See the line along which the force is acts. So this is the line along which this force is acting. So it is called as the line of action. Okay, and the arrowhead of this force will give you the direction, which points the direction. These both points have been told in this direction, under direction. So now third is the point of application. Third is point of application. So in the point of application, we can write the point at which the point at which force is applied, the point at which the force is applied on a body is known as point of application. Point of application. Is there any problem in these three characteristics which I have told to you?
No, sir.
Have you taken down the notes so that we will move to the next board, next slide?
Yes.
Okay. So now, and the last thing is that now the nature of the force. Okay, whether it is push or whether it is pull. So how to decide the nature of the force? Okay, so that nature we can decide from the arrowhead. Now that point we will take the next. So fourth is the nature of force. Nature of force. What kind of force it is, that we are going to see. So in the nature there are two types. First is, this is the fourth nature of force, and in that first is push and second type is pull. Push and pull. Sometimes on the doors of the ATM, when you go to the ATM, you can see that on that door it is written push or pull. Accordingly you do the thing. If push is written, you push the door inside. If pull is written, then you pull the door outside. Okay, so that in that way you apply the force to open that door. So there basically there are two natures related to force. One is push, another is pull. So first of all we will see this push. First is push. So if the arrowhead is pointed, if the arrowhead is pointed towards the point of application, towards the point of application, then nature of force, then nature of force is push, is push. Okay, full stop. It is also called as compressive force. Compressive force. Okay. So best example is the opening the door. When you go to ATM, if you see on the door it is written push, what you do? You push that door inside. Okay, so what exactly you are doing? So your arrow is like this. Your arrowhead is coming towards that door, and you are pushing that door inside. So that nature is the push nature, and it is also the compressive nature. Okay, this is also called as the compressive force, compressive nature. So if we draw the diagram of this, then diagrammatically we can show it like this. Suppose this is the surface. Now on this surface a body is resting. Suppose this is a body, and now on this body the force is acting, and this force, it is of nature like this. This is the force. Let us say that this is force F. Force F is acting. Now we can see over here this arrowhead. This is the point of application. Okay, so it is acting towards the point of application. म्हणजे point of application कडे act होतोय, towards the point of application, then it is push. And if it is acting away from point of application, then it is pull. Pull म्हणजे काय करतं? दरवाजा तुम्ही ओढता ना, म्हणजे तुम्ही काय करता एक्झॅक्टली त्या दरवाजाला पकडता आणि तिथं पुल लिहिलेलं आहे म्हटल्यावर तो दरवाजा तुमच्या बाजूला तुम्ही ओढून घेता. म्हणजे डायरेक्शन कसं आलं? दरवाजापासून तुमच्या साईडला आलं फोर्सचं. म्हणजे तुम्ही ज्या पॉइंटला फोर्स अप्लाय करताय त्याच्यापासून त्याचा अॅरोहेड कसा येणार? अवे येणार. डायरेक्शन कुठे येणार? तुमच्याकडे येणार. दॅट इज पुल. आणि पुशला काय? तुम्ही त्याच्याकडे ढकलताय, डोअरला आत ढकलताय. दॅट इज नथिंग बट पुश. So here you can see, if I draw again, so here this may be our line of action of force. So this is the line of action of force. This is very important, line of action of force. Okay. This is line of action of force. So I will write over here, what is this? The line of action of force, or this is also called as line of action only. Then this point which is over here, this point, this is called as, this is point of application. This is called as point of application. And this total diagram, this is push nature. This is push or compressive nature. This is push or compressive nature. So this is the point. Suppose now here it is the point, and if I apply the load like this, okay, if I apply the force like this, I am applying the force on this. So my arrowhead is pointing towards the point of application. It is towards the point of application. त्याच्याकडे चाललाय माझा arrow. म्हणजे तो काय असणार आहे? पुश असणार आहे. पुश, compressive. So is it understood?
Yes.
Yes.
Yes, sir. Yes, sir.
So now the next nature is pull. So second is pull. This is the basic things, but these concepts are very important. When we see the second section and the next topics of the first section, you may get confused within the compressive forces and tensile forces, push and pull. So that right now, be clear with these things. What is push and what is pull? So now next is the pull. So next is pull, and regarding pull we can say that if the arrow head is pointed, if the arrowhead is pointed away from the point of application, then the nature of force is pull, full stop. It is also called as tensile force. The best example of pull or applying the tensile force is with the help of rope. Rope म्हणजे काय? दोरी. Okay, rope. So you always see that by using the rope, समजा आपण रोप म्हणजे दोरी एखाद्या गोष्टीला बांधली तर आपण दोरी बांधून नेहमी ओढू शकतो. दोरी बांधून ढकलता येते का कधी?
नाही.
कधीच येत नाही. हॅव यू ऑब्झर्व? दीज आर द थिंग्स विच आर डुईंग डेली इन अवर लाईफ. बघा काय काय वेळेला आपण म्हणतो काहीतरी ओढायचंय, आणायचंय, एखादी दोरी हुडकतो, त्याला बांधतो आणि आपण त्याला ओढून आणतो. कुठली काही ऑब्जेक्ट असेल, व्हॉट एव्हर इट मे बी, व्हॉट एव्हर मे बी द ऑब्जेक्ट. सो यू कॅन ऑब्झर्व दॅट बाय युझिंग द रोप we can only apply the pull force, that is the tensile force. By tying the rope we cannot apply the push force, we cannot apply compressive force. Okay, but instead of rope, now if you use a steel bar, okay, एखादा बार यूज केला तुम्ही असा जाड चांगला, स्टील असू दे, लोखंडाचा असू दे, काही असू दे, but by using that bar you can apply tensile force as well as compressive force. You can push the bar also. Okay, because it is stiff, the stiffness of bar is high. Okay, and in the case of rope what will happen, if you try to pull, ती दोरी सरळ राहणार नाही, ती zigzag होऊन जाईल किंवा ते प्रेशरच अप्लाय होणार नाही. Okay, so the stiffness of rope is not that much high as that of the bar. So that is why we cannot apply the push force by using the rope. But if we use a steel bar or iron bar, whatever it may be, that bar, it is solid in nature, it is having the more stiffness, so we can apply the push force as well as pull force. So this is the pull force. In the main point in this force is, you can observe over here, the arrowhead is pointing away. This word you should remember. If it is towards, then it is push. If it is away from the point, then it is pull. Okay, so away from the point of application, then it is called as pull. This is also called as the tensile force. So if we draw the diagram of this, I will draw diagram like previous one. So here again the surface is there on which a block is resting. Now this time the nature of the force, if you apply the force, so this is the nature of the force. So this is pull. This is nothing but pull. F kilonewton is the force as usual. This is our point of application. Now see, your arrowhead is away from point of application. This is your point of application. Point of application. So you can see your arrowhead. Head of the arrow is away from point of application. So we call this force as a pull or tensile force. And the line of action, the concept is again same. If I draw over here the line of action, it will be like this. This is the line of action of this force. This is called as line of action. You can draw the line of action like this. This is line of action. Line of action of force. So you can call this as a pull or tensile nature. This is pull or tensile nature. Is it clear? What is push and what is pull?
Yes.
Always you need to see the point of application first. First thing काय बघायची? Always you see where is the point of application and see the arrowhead. If that arrowhead of the force is pointing towards the point of application, like the previous one, if it is pointing towards, here you can see, it is pointing towards the point of application, then it is push or compressive. Then it is push or compressive. And if it is pointing away from a point of application, this is pointing away from point of application, then this is called as pull or tensile force. This is called as pull or tensile force. So this is about the characteristics of the force. So force is characterized based on its magnitude, then direction, then point of application, and after that, nature of the force. Nature of the force. So based on this, now collectively we will study the system of forces. So our next point is the system of forces. Is it over? Have you taken down the notes?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so the next point, next is the system of forces. Next point is the system of forces. So for that, we will see first what is the meaning of system, okay, or the system of force. System, we can define it as when, it is very easy, you can write it with me, you will understand while you are writing. When two or more forces, when two or more forces acting on a body, acting on a body, they forms system of forces. System of forces. So this system of forces. So what is the meaning of system of forces? When two or more than two or two. The criteria is two or more than two. A single body is there, whatever may be rigid body, any type of nature, if the body possesses, then on that body, more than two or two, so more than one actually, so two or more forces are acting on that body, then those that is called as, or they will form the system of forces. Those forces are called those forces are known as, those are in the system of forces. So that is nothing but the system of forces. It is when two or more forces acting on a body, they forms system of forces. So now we will see the force system, how it is. So the system of forces. System of forces. So basically the forces are divided into two categories. First is the coplanar forces, second is the non-coplanar forces. So the coplanar forces and non-coplanar forces. So we'll draw the diagram for this. You also draw with me. Whatever you are writing now with me, those are only your notes. Those are the notes. Okay, this I am taking from my past experience and also by referring many of the books. So this is the best notes for you. So at the end of the semester, don't tell me sir notes they are हे जे तुम्ही लिहून घेताय, these are very good notes. And for MCQs, I will provide you the separate notes based on MCQs. So now the system. So I am telling you, write it down with me. Don't miss it. So the system of force. So first it is divided into coplanar forces. Coplanar forces. And second is non-coplanar, basically divided into two categories. Non-coplanar forces. So non-coplanar forces are not further divided into any types, but the coplanar forces are further divided into four types. So those types we will see now. So the coplanar forces, these are further divided into four types. So now first type is the collinear forces. First type is collinear forces. Collinear forces. Second type is concurrent forces. Concurrent forces. Then third type is non-concurrent forces. Coplanar non-concurrent. Non-concurrent forces. And the last type, it is parallel forces. Last one is the parallel forces. Okay, but these parallel forces are again divided into two categories. These parallel forces are again divided into two categories. So first is the like parallel forces and unlike parallel forces. Parallel forces are further divided into two categories. So like parallel forces, like parallel forces, and second type is unlike parallel forces. Unlike parallel forces. So this is your system of force. This is your system of force that we are going to study. So the system of force is basically divided into two categories: coplanar forces, non-coplanar forces. Then further coplanar forces are divided into four categories: collinear forces, concurrent forces, non-concurrent forces, parallel forces. After that, these parallel forces are also again divided into two categories: like parallel forces, unlike parallel forces. So this whole, it is known as the system of forces. This is together known as the system of forces. Now we will see each system one by one. So first of all, we will go for coplanar forces. We will go for the coplanar forces first. So here, coplanar forces. Coplanar forces. So I will write what is the coplanar forces. So from the name itself, you can say that what is the coplanar? The forces which are acting in the same plane. The forces which are acting in the same plane are called as coplanar forces. If you consider XYZ like this, three mutually perpendicular axes, XYZ like this. Okay. So suppose this is your x-axis which is horizontal. This thumb is the y-axis which is vertical, and this first finger is the z-axis which is pointing towards this direction. Okay. This is y, x, and this is z. X, Y, Z, three mutually perpendicular axes like this. Okay. So you can say that how many planes are there? Then XY is the one plane, then XZ is another plane, then YZ is the plane. Okay. XY, XZ, YZ. These are the planes. So in that plane, if the force is acting anywhere, then we can say that if the force are acting at the different planes, then it is non-coplanar forces. If the number of forces which are given to us are acting in the same plane, then we will call them as a coplanar forces. So here I will write when So before writing, I will draw the diagram. Okay. So suppose now three mutually perpendicular axes are there. This is your x-axis. This is x-axis. Then this is y-axis. And now I will show the z-axis like this, but you see that these are three mutually perpendicular axes. X, Y, Z. The angle between them is 90 degree. Three axes are there, X, Y, and Z. Now in this plane, if I want to show the coplanar forces, if I want to show the coplanar forces, so how I am going to show those coplanar forces? See, this is one force. This is F1. Then this is F2. Here the another force. This is F3. And let us take one more. This is F4. So here you can see all these forces are F4, F4, then this is F1, this force is F2, this force is F3. So all these forces are acting in a single plane. If I give the name to the axis, so this is my x-axis, this is y-axis, and this is z-axis. Here you can see all these forces are acting in xy plane. All the forces are acting in xy plane, F1, F2, F3, F4. So we can call them as a coplanar forces. The same thing now I am going to write over here. When number of forces, when number of forces acting in the same plane, then forces then the forces are called as coplanar forces. Then the forces are called as coplanar forces. Yeah. So similarly, we are going to see what are the non-coplanar forces. So now non-coplanar forces. Non-coplanar forces. So first I will write the definition, then the diagram. Now I hope now you understood what are the coplanar forces and non-coplanar forces. If you are having any doubt, you can ask. So when number of forces are acting in different planes, then the forces are called as non-coplanar forces. Non-coplanar forces. So again, if I draw the diagram, then non-coplanar forces will be x-axis, y-axis, z-axis. These are the axes x, y, and z. So this is x, this axis is y, this axis is z. So now see if the forces are acting like this. Now I will draw the forces. So here F1 force is acting. So this my force is F1. So somewhere here F2 force is acting like this. This is F2. And now my third force, if it is acting over here like this, this is F3. So my third force F. Now you can see over here, your F1 force is acting in XY plane. Your F2 force, it is acting in YZ plane. And F3 force, it is acting in XZ plane. F1 XY, F2 YZ, and F3 XZ. So all the three forces, F1, F2, and F3 are acting in three different planes. So those are called as non-coplanar forces. Those are called as non-coplanar forces. Now after this, here you can see we have seen right now what is the system of forces, that definition we have seen, then coplanar forces and non-coplanar forces. These two things we have gone through. Now we will move to the subtype of the coplanar forces, and that is collinear forces. So we will move to the next point, that is collinear forces. So the next heading is collinear forces. So first I will write down the definition, and then we will draw the diagram. When the number of forces are acting on same line of action, then the forces are called as collinear forces. Then the forces are called as collinear forces. Very easy. When the number of forces are acting on same line of action. I have just explained you what is line of action. Okay, when a force is there, if you extend its head and its tail, dotted line you can draw. That line is nothing but that is the line of action of that force. So when the number of forces are acting on same line of action, then the forces are called as collinear forces. So I will draw here collinear forces. First, what I will do, I will draw the line of action first. Okay. Now suppose this is the line of action. This line is line of action. So this line is line of action. I won't give the name right now. After the diagram, I will give the name. So now on this line, suppose here the force F1 is acting at this point. So this is the force F1. This is the force F1 which is acting at this point. Force F1. Then suppose now second force is there. Another force which is F2. This is also acting in this way on this same line. So this is your force F2 which is acting over here. This is the point. Now if I consider the third force, this is my third force, and this is F3 which is acting like this. This is F3. So we are not mentioning about the direction. एकाच direction मध्ये असायला पाहिजे वगैरे असं काय नाही. The only criteria is that when the number of forces are acting on same line of action. Now here you can see I can call this line as a line of action. This is line of action. Or if you can extend any of the head. दुसरं काय की ह्याच्या हेड मधनं तुम्ही डॉटेड लाईन ड्रॉ केली तर ती इथूनच जाणार आहे, आणि टेल मधनं ड्रॉ केलेली डॉटेड लाईन अशी जाणार आहे. सेम वे कुठलाही फोर्स कन्सिडर करा. इफ यू ड्रॉ द डॉटेड लाईन फ्रॉम द हेड of F2 force, then it will be on the same line of action of this F3. And if you extend that line of action backward side of F2, then it will pass through F1. So you can see that similar cases with the F1 also. If you extend from back side, then there is no force. But if you extend from the forward side, from the head of F1, if you extend the line of action, then F2's force is also acting on the same line of action, and F3 is also acting on the same line of action. So these forces F1, F2, F3 are collinear forces. F1, F2, F3 are collinear forces. Here there is no question of direction. F1 and F2 are moving towards right,
Hello, sir. Your
Hello,
mic
sir.
is mute, sir.
Okay, sorry. Okay. So what was I am telling? It doesn't matter whatever is the nature of the force. It may be compressive, it may be tensile, it may be push or pull. Push or pull ला दूसरा नाव है compressive and tensile. Okay, it may be compressive, it may be tensile. It doesn't matter. But if the forces are lying on the same line of action, the line of action may be horizontal, the line of action may be vertical, or the line of action may be inclined at an angle theta. Whatever may be the line of action. Okay, if the forces are acting on the same line of action, then those are called as the collinear forces. The screen is visible to all of you, white screen.
Yes,
Yes.
sir.
हा
Yes, sir.
पहिले केलेली स्क्रीन गेली ते डिस्कनेक्ट झालं ना. Once the zoom is getting disconnected due to net problem, then first thing or first screen whatever we have drawn, that will not get saved. Okay, so again instead of drawing the diagram, if it is understood to you, then we will move to the next force. Or is it necessary that I should draw the diagram again? Collinear forces.
No, sir.
Okay. So collinear forces, you just remember one thing, collinear forces may be like this also. Now if I draw this vertical line of action, so I can say that this forces, whatever right now I am showing now. So this is F1, so this force F1, then this force F2, then third force. Now I will show all the forces in same direction now. This force F3. So all these are the collinear forces. All these are the collinear forces. F3, then this is your F2, and this one is the F1. All these are the collinear forces. आता हे जे उभं आपण ड्रॉ केलं ना, vertical, the line of action is vertical. You can incline this at any angle theta. कसं incline करा, these will remain on same line of action. याला horizontal करा, आडवं करा याला, so that then also it will remain on same line of action. So these forces are called as collinear forces, and it is doesn't depend upon the direction. असंही असू शकतं F1 F2 एका डायरेक्शनला, F3 दुसऱ्या त्यांच्या अपोजिट डायरेक्शनला, किंवा F1 F3 एका डायरेक्शनला, F2 अपोजिट डायरेक्शनला. Direction doesn't matter. Okay, the only thing is that you have to see the line of action. See, if you see F1 F2 and F3, the line of action of F1 F2 and F3 is a single line. So these forces are called as collinear forces. Okay, so we will move further. Now next is after the collinear forces, next force is the concurrent forces. So next is the concurrent forces. Concurrent forces. So the concurrent forces means what? The forces which are acting at same point, which are acting at same point are called as concurrent forces. Very simple and easy definition. Okay, concurrent forces. If the number of forces are acting on the same point, then those forces we can call them as a concurrent forces. So the forces are acting on the same point. So now if I draw one point over here, suppose now this is the point. Okay, this is the point. Now if the number of forces are acting on this point, let us say that this is the force F1. F1 is acting like this. Okay, then the next force is F2. F2 may be acting like this. Next force is F3. F3 may be vertical like this. Okay. Next force is F4. Let us say that F4 is acting in this direction. This is F4. F4. So all these forces are nothing but the concurrent forces. All these forces are nothing but concurrent forces. They may have same magnitude, they may have different magnitude, whatever may be. F1, F2, F3 represents the different magnitude. Okay. So all these are called as forces are called as concurrent forces acting on the same point. So the forces which are acting on the same point, those are called as the concurrent forces. Those are called as concurrent forces. Okay. So next is the non-concurrent forces. Next slide. Next in the next point. Next कुठला force non-concurrent आहे ना? Next is non-concurrent forces and after that parallel. आता non-concurrent म्हणजे काय असेल तुम्ही सांगा. Concurrent म्हणजे मी काय सांगितलं? What is concurrent? When the forces are acting.
Point.
Acting at a different point.
Correct.
And non-concurrent.
Non-concurrent means what? It is acting at different points. So that we will see now. So non-concurrent. So here non-concurrent forces, I will give the heading non-concurrent forces. So the non-concurrent forces are the forces which are lies in the same plane because this is the type of coplanar force. So all these forces are in the same plane but acting at different points are called as coplanar non-concurrent forces. Coplanar non-concurrent forces are called as non-concurrent forces. Now again, if I draw the axis XYZ, so this is x-axis, then y-axis, and third one is the z-axis. These three axes are mutually perpendicular to each other. This is x, y, and z. Now if I show the force, this is F1, F2, F3, and F4. So all these are coplanar but non-concurrent forces. All these are F3, then this is, I can say that this is F1 and this force is F2. So you can say that F1, F2, F3, F4 are non-concurrent coplanar forces. Okay, they are in the same plane but they are non-concurrent forces. So after this we will move to our last type, parallel forces. Next is the parallel forces. Now you can tell me what are the parallel forces? You are knowing this parallel forces. How will you define the parallel forces?
The forces acting parallel to each other are called as parallel forces.
Correct. So in the another language we can say that the forces whose line of action, okay, the forces whose line of action are parallel to each other, then those forces are called as parallel forces. Okay, the forces which are not going to intersect anywhere, those are the parallel forces. म्हणजे असं पण असू शकतं बरं का, हे लक्षात घ्या. Suppose now if I draw the force, see this is our F1 force And if I draw another force, this is F2 force. This is F2 force. Now I will give the name. This is F2 and this force is F1. Now here if you see that these two forces are not what we can say, not parallel forces. These are not the parallel forces. How you can say that? Because when you extend their line of action, now if I extend the line of action towards the back side, and if I extend their line of action on the front side, it will be like this. Similarly, if I extend the line of action of x2 on the tail side, then it will be like this. On head side, then it is like this. So if you extend the line of action of these two forces, then these two forces are intersecting at this point. These two lines of action are intersecting somewhere. So these two are not the parallel forces. We can't say them as a parallel forces even though they are not intersecting in front of us right now. Right now if you see, F1 is at different location, F2 is at different location. Okay, they are not intersecting in front of us. But when we extend their line of action, they will meet somewhere. They will meet somewhere. They will intersect each other. So these forces are not the parallel forces. Parallel forces are the forces whose line of action never meet each other. They will remain parallel as it is. तुम्ही किती extend करा, वर extend करा किंवा खाली extend करा, they will not meet each other. They will not intersect each other. So these forces, those types of forces are called as the parallel forces. So for the parallel forces, now we will write the definition for the parallel forces. So the definition for parallel forces, it is if म्हणायच्याऐवजी डायरेक्ट द फोर्सेस पासून घेऊ, the forces whose line of action are parallel to each other, are called as parallel forces. Full stop. They are further divided into two types, and those two types are, first, it is like parallel forces, and second type is unlike parallel forces. Okay, so I think time is over now. Remaining part we will cover in the next lecture. I think in the afternoon also we are having the lecture. So in that lecture we will cover the further part. So now for today we will stop over here, and let me take your attendance. Just wait. Okay, so today is the date, I think 20 December 2021, FYB division M. Attendance of time 11 to 12. Okay, so roll number 1,
Present.
2.
Present, sir.
Okay, I will also open the chat. If you face some problem while switching on the mic, you can raise your hand in the chat, or you can answer me in the chat also, your roll number. So roll number 1.
Present.
Right? Okay, 2.
Present, sir.
3.
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12, 12 is absent. 13,
Present, sir.
14,
Hello, sir. 12 is present.
okay, 12 is present, 13 is present, 14,
Present.
15,
Present.
16, 17,
Present, sir.
18, 19,
Present.
20,
Present.
21,
Present.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31, 31 is absent, 32,
Present, sir.
33,
Present, sir.
34, 34, 35,
Present, sir.
36, 37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40, 41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44, 45, 46,
Present, sir.
47, 48,
Present, sir.
49, 50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53, 54,
Present, sir.
55, 56, 57,
Present, sir.
58, 59, 60, 59 is present, 60, 61, 62. Okay, so I will tell the absent roll numbers once again. Now, if somebody is present, you can tell me. Roll number 18, 31, 36, 40, 45, 47, 49, 53, 55, 56, 58, 60, 61, 62. So these are the absent roll numbers. Okay, 44, you are not in the absent list. I have seen you while you speak now. Your comes number and name comes in the participant, so I am able to see that. So these are the absent roll numbers. Anybody from these roll numbers which I have counted over here right now? Somebody is present? Okay, so no one is there. So we will stop over here. In the next lecture, we will cover the further part. Okay, thank you.